Hey everybody, today's video we're going to talk about ratios and what are ratios and ratio tables more specifically, because I'm going to introduce that idea. So you guys have seen a rectangle like this before, and usually you might be asked the question, how much blue is in the rectangle? Okay, and then you would write a fraction. So instead of using the fraction in a typical way, we are going to talk about it in terms of ratios. So ratios are the same idea as fractions, but instead of comparing to the whole, you are actually comparing two different things. And I'll show you an example. So typically, as I just said, if you were looking at this in terms of a fraction, you might be asked the question, how much of the rectangle is blue? Okay, and then you would write maybe, depending on how you see it, 3 out of 18. So what you're doing is comparing the part that's blue to the whole of the rectangle. Now, if we use ratio, we're actually asking a different question. So in ratio, you would be asked maybe a question like this. How many blue are there compared to red? In this case, you would be writing the fraction 3 compared to 6. So in this case, you're comparing two different things. You're comparing blue to red rather than comparing part to whole. So ratios can be written in a few different ways. Ratios can be written as a fraction, as 3 out of 6. So like this here, okay, as a fraction, or in what is the more unique form of ratios, which is 3 compared to 6. So with these two dots in the middle. Now the other way that it can also be written is in what's called a ratio table. Okay, so in that case, you would put in a table with your two objects and comparing them. Okay, so with ratio tables, what's great about them is that it's very easy to discuss equivalent fractions. Okay, so if once again we look at this image and we say, if there are 3 blue and 6 red, then if you looked at it like 1 blue, there would be 2 red. Okay, so if we wrote that in fraction form, we would have something like 3 over 6 is equal to 1 over 2. And then if we move that into a fraction table, it's just the same thing. So 3 compared to 6 and 1, or 1 compared to 2. Now, if we chose to divide this differently, so we could say if there are 1 blue and 2 red, then if you looked at it like 6 blue, and divided that section into 6, then we would have to look at the red, then the red would be 12. Okay, so you're dividing it or breaking it apart or multiplying it in different ways to get equivalent fractions. So 3 compared to 6 is the same as 1 compared to 2, which is the same as 6 compared to 12, depending on how you chose to divide it. Okay, and we can put that into a ratio table. So here's another rectangle. Okay, so in this case, let's compare red to purple. So if we look at our image, if there are 6 red, then there would be 12 purple. However, if we chose to look at it as 2 red, then using that same size, there would be 4 purple. Okay, and if you notice in our in this ratio table here, okay, so here we have our ratio table. Okay, if I can just draw your attention to that, then you can see that within the ratio table I have 6/12, 6 compared to 12, or I can change that 2 compared to 4. And then if I look at the numbers and say, well, what's the relationship between those? I basically took 6 and I divided it by 3. And what I do to one side, I'd have to do, or what I do to the top, I would also have to do to the bottom. So 12 divided by 3 is 4. And so I can build different relationships and equivalent fractions just by either multiplying or dividing those numbers within the rows. So again, if I looked at this differently and broke it apart differently, I could say if there are 6 red, like we had originally, and 12 purple, then if you looked at it like 12 red, there would be 24 purple. So in this case, I am taking that those original squares, and I'm essentially multiplying by 2. So when there were 6, I'm now changing it to 12 red. So I times the 6 by 2 to get 12. And then same with what I do to the top row, I have to also do to the bottom row because there's a relationship between the two. So I get 12 times 2 is 24. So you can create multiple different kinds of equivalent fractions just by either multiplying or dividing the numbers within the rows. So in the work that you're going to be doing today, we're going to be giving you a ratio table. You're going to be given a situation, and then you're going to use the ratio table to find the solution. And once again, you may not use every column in the ratio table. It's just there, and you decide what numbers or which columns you're going to use, or how many columns you're going to use or not use. So in this situation, we are told that there are 5 pieces of gum in a pack, in one pack. So if you notice in my ratio table, I have a pack. How many packs are there? There's one pack. How many pieces? Well, there's 5 pieces within the pack. So the question you're trying to answer is, if there are 5 pieces of gum in one pack, how many pieces of gum are there in 10 packs? Okay, so I look at those numbers and I say, well, what did I do to 1 to get 10? Okay, and I can see that I went from 1 pack to 10 packs, so that would be like multiplying by 10. Okay, so if I do that to the top, I also have to do that to the bottom. And I can think about, if I have 5 packs, if I have 10 packs of gum and 5 in each pack, then I would also be timesing that. So 5 groups of 10, which would give me 50. Okay, so you're going to use those ratio tables to find your solution. All right, so you can head to the Google Slides now and try and answer some of those questions and keep any issues you're having or questions you have for our Google Meet. All right, bye for now.